In our last video, we started talking about factoring, GCFs and trinomials specifically. In today's lesson, we'll be talking about special factoring. So we'll look at some special trinomials and some binomials that are dot problems and cube problems. The first type that we're going to start is what a lot of your teachers at Marquette refer to as dots problems, difference of two squares. And this should make sense with the name because difference refers to that there's a subtraction in the middle of there are two terms, and squares. You'll notice here I can take the square root of x squared and I can take the square root of 100. So when this happens, basically, you can kind of think about it. If this was a third term, it would be 0x. So what two numbers multiply to give you negative 100 but add to give you 0? That would be 10 and 10. One would be a positive 10, one would be a negative 10 in order to cancel out and give you that 0. So with a difference of two squares, basically, if you take the square root of that number, that will always give you that last term, as would taking the square root of the first. By doing it, it kind of cancels out the middle. Now, if we look at example number 2, if we took a look at this one, we have y to the 4th minus 16. And this still fits the dots. I have a subtraction sign, and I can take the square root of both of them. So I'll set up my two binomials, and if I take the square root of y to the 4th, it's y squared and y squared. And if I take the square root of 16, it's 4 and 4. One will be plus, one will be minus. Now, the trick to some of these is that sometimes they can be factored again. Now, this right here, I cannot factor again because you'll notice that the middle term is a plus. But if we come and we take a look at the second one, it fits the dots requirement again. Subtraction sign, and I can take the square root of both. Y and y, 2 and 2. One a plus, one a minus. And then I drop down that original y squared plus 4. So I actually have 3 binomials that this factors down to. Now if we look at example number 3, we have 3 terms again, trinomials. And if we kind of think about the process from the last video, two numbers that multiply to 16 that add to negative 8 are negative 4 and negative 4. So x minus 4 and x minus 4, which is x minus 4 squared. Now, what makes this a little bit special, as you can tell that they have the same negative 4 and negative 4, and this is because it is considered a perfect square trinomial, a PST. And the reason why it's a PST is because I can take the square root of this, square root of that, and if I double it, it gives me the middle number. So the square root of x squared is x, square root of 16 is 4, and if I double this, that gives me 8x, which is the middle number. Now, in this case, it might not seem like that big of a help or a trick to shorten it out. But if we take a look at number 4, where we have some larger coefficients that do not have GCFs in them, and if we look to see if those are PSTs, I can take the square root of that, which is 3a. I can take the square root of the last, which is 8b. If I multiply it, it gives me 24ab. And if I double it, it gives me 48ab, which is that middle number, meaning it fits the PST requirements. So then all I have to do is create a binomial and square it. I take the square root of 9a squared, which is 3a, that becomes my first term, and I take the square root of 64b, which is 8b, and that becomes my second, and then the term drops down. And I don't have to do any factoring by grouping, just take the square root of the first and the last. And finally, the last special type of factoring are going to be cube problems. And there are actually 3 sets. If we have perfect cubes that are binomials, they can be addition or subtraction. Subtraction has the following format. A cubed minus b cubed can be factored to a minus b times a squared plus ab plus b squared, while a cubed plus b cubed equals a plus b times the quantity a squared minus ab plus b squared. And then basically it's just a matter of plugging it into each one of these kind of formulas, if you want to call it. So if I look at number 5, I can take the square root of x cubed, that would be x, and I can take the cube root of 1,000, which would be 10. So I'm going to rewrite it that way, x cubed minus 10 cubed. And you'll see that it kind of fits this top on this difference. So my x is a, my 10 is b, and then I just fill it into that. So x minus 10, that's that a minus b. A squared now is x squared plus a times b, which is x times 10, or 10x. And then finally b squared, which is 10, so 10 squared is 100. And then that's all you can do. Usually you cannot factor that trinomial, so you would just be the binomial times the trinomial. Finally, if we take a look at this one, we're able to do trinomials, we're able to do cube roots of each of those terms. The cube root of 27 is 3 cubed, m cubed, plus 4 cubed, n cubed. And this one happens to be the sum. So again, I'll just rewrite this a little bit different. And now my a is 3m, and my b is 4n. So anytime I see a, I put in 3m. Anytime I see b, I put in 4n. So it's going to be 3m plus 4n times the quantity 3m squared, which would be 9m squared, minus 12mn. Again, I just multiplied the a and the b, which is now 3n times 4n, plus 16n squared, which again is 4n squared. And then that would be the factored sum of cubes.